Hey there, class. Mr. Husky here. Hope you're having a good day so far. We're continuing with Chapter 5. This is measures of center of triangles. One of the measures of center of triangles are perpendicular bisectors, which we'll learn about today. And then the point of concurrency, or where the perpendicular bisectors meet, is called the circumcenter, which is basically like kind of one of the centers of a triangle, basically, okay? All right, why don't we, the name of this lesson is, this is 5.2, use perpendicular bisectors. Our essential question is, how do I use perpendicular bisectors and their properties to solve problems? We have a warm-up, which is kind of a problem from 5.1. We're solving for x using mid-segment and the third side of triangles. Why don't you guys go ahead and pause the video and see how you do. Okay, so what do we know here? Well, what's the third side here? KM is the third side. Is that going to be double or half the mid-segment? It's going to be double the mid-segment. The mid-segment is HI. So Km was 2x minus 4 equals double HI, which is 2x minus 11. Okay. All right. Now we got to solve this. We're solving for x. So we box that. We're looking for x. What's the first step? Is there anything to distribute here? Yep. We got 2 to 2x and 2 to negative 11. 2x minus 4. What's 2 times 2x? 4x. And what's 2 times negative 11? Negative 22. All right, how do we solve for x now? Probably subtract 2x from both sides would be a good idea. So we have negative 4 equals 2x minus 22. Now what? Add 22. And what is negative 4 plus 22? That is 18 equals 2x. Divide by 2. We get 9 equals x. And there's our answer. Okay, sounds good. So a perpendicular bisector is a segment, ray, line, or plane that is perpendicular to a segment at its midpoint. At its what? At its midpoint. Okay. All right, so basically if I draw like a line here, I'm just going to draw a line like this. And so we have 3 points here. A perpendicular bisector would be right at the midpoint, which means these are congruent. Those are not great tick marks there. Like this. These are congruent. And also, there's a ray. This would be a right angle. That's an example of a perpendicular bisector. Okay? All right, equidistant. Say equidistant. Equidistant is a point that is the same distance. Does the what? Same distance from one figure to another. All right? Concurrent. Say concurrent. Concurrent is when 3 or more lines, rays, or segments intersect at the same points. The same what? The same point. And they're called concurrent when that happens, when they intersect. Point of concurrency is the point of intersection. The what? The point of intersection of concurrent lines, rays, or segments. And circumcenter. Say circumcenter. The point of concurrency of the 3 perpendicular bisectors. The what? Perpendicular bisectors of a triangle. Okay. So it's where all the perpendicular bisectors intersect in the middle of the triangle. Okay. All right. Sounds good. Here's some perpendicular bisector theorems and converses here. So in a plane, if a point is on the perpendicular bisector of a segment, then it is equidistant. Is what? Equidistant from the endpoints of the segment. So basically, a point that's on this line right here are going to be CA. These are going to be congruent, basically. These distances are going to be the same, okay? These are going to be the same, okay? So CA equals what? CB, all right? So basically, like if you have a point that's on the perpendicular bisector, it's going to be the same distance from these points that are on the endpoints of the perpendicular bisector, okay? Converse is also true. If a point is equidistant, if these are equidistant here, that means that D is on the perpendicular bisector. The what? Perpendicular bisector. So it's basically goes both directions, right? If it's on the perpendicular bisector, it's going to be equidistant from the points, and vice versa. If it's equidistant, then it's also going to imply it's on the perpendicular bisector. Okay? Perpendicular bisector. All right, sounds good. Okay, sounds good. So let's go ahead and do this example 1. It says use the perpendicular bisector theorem. It says JN is the perpendicular bisector of MK. Find ML. All right. So we know A is 3y plus 16, and we know B is 6y plus 10. Okay. But we know that there's some tick marks here that these are congruent. So if they're congruent, what are we going to do to them? Well, we're going to set them equal, right? So we're going to do 6y plus 10 equals, actually, let's rewrite this here. I'm going to write before we do that. So what we know is that KL is equal to ML, okay, because of the tick marks here. So now we can do our 6y plus 10 equals 3y plus 16. Why don't you guys pause the video and see if you can solve this from here? All right, and also we're looking for ML, by the way, so we need to do that. Okay, let's solve for y. We're going to subtract 3y from both sides. So we have 3y plus 10 equals 16. What's next? Minus 10. 3y equals 6. How do we solve for y? Divide by 3. So we get y equals 2. Are we done? No, we got to find ML. Well, ML was 3y plus 16. So we're going to plug 2 in for y. So ML equals 3 times 2 plus 16, which equals 6 plus 16. Right, very sloppy. 6 plus 16. So ML is going to equal 22. And also KL should also equal that too because they're congruent, but that's what we wanted. So, all right, very cool. Okay, checkpoints. Yeah, why don't you guys go ahead and pause the video, see if you can do these. Give them a try. All right, we know that JK is the perpendicular bisector of GH. Find GH. GH is this distance right here. Okay. If this is the perpendicular bisector right here, what do we know about this length and this length? They are going to be the same. So we're going to do 2x equals x plus 1. How do we solve for x now? Subtract x. So we get x equals 1. Are we done? Nope. Excuse me. We got to find GH. And GH was 2x plus x plus 1. Is that entire distance? We can plug in 1 here. So we got 2 times 1 plus 1 plus 1. So that's going to be 2 plus 1 plus 1. And GH is going to equal 2 plus 1 plus 1 is 4. And there's our answer. All right, how about number 2? AC is the perpendicular bisector of BD. Find AD. Okay, if this is the perpendicular bisector, that means what about these lengths here? They are congruent, so we're going to do what? We're going to set them equal. We're also looking for AD, by the way. So we're going to set them equal. 7x minus 6 equals 4x. How do we solve for x now? I probably subtract 7x from this side because you're going to have, otherwise if you move the 4x over, you're going to have 0. And what's 4x minus 7x? That's negative 3x. Divide by negative 3. And x equals 2. All right, so now we have AD. We're looking for AD, which is 4x. So 4 times 2. So AD is going to equal 8. All right, sounds good. Okay, there should be a handout in this chapter that's going to explain a lot of these things. There's some kind of properties of like perpendicular bisector concurrency, circumcenter, orthocenter, stuff like that, medians, stuff like that. So there's a kind of a weird, there's kind of a rule for circumcenter, okay? So P, so these are all right here. These are all the perpendicular bisectors, okay? These are perpendicular, perpendicular, perpendicular. These are all the perpendicular bisectors right here, right? Okay, so the rule is P, this is where they all cross, okay? And the rule is that these highlighted lengths right here are all going to be congruent, okay? It's just kind of a property of the perpendicular bisectors. They are equidistant, the circumcenter is equidistant from the corners or the vertices of the triangle, okay? So PA is congruent to what? PB and PC. Okay, so those are all equidistant. I'll put 4 tick marks here. 4 tick marks, 4 tick marks. Okay? All right. Sounds good. So let's get into this here now. So it says, in the diagram, the perpendicular bisectors of triangle ABC meet at point G. Given that GC equals 14 and GF equals 13, find GB. Why don't you think about this one for a second and see if you can figure it out. Well, this is the circumcenter right here, which means these are all going to be the same distance right here. So if GC is 14, what is this going to be equal to? GB is also going to be equal to 14. There's actually no work needed for this one. That's it. So they try to trick you a little bit. Okay, and I think that is all I have for you for today. So thank you for watching. Have a great day, and we will talk soon.